Today we are going to continue with chapter 5, work method. In the previous class, we already learned some application of work method, and we already learned about the independent mechanism and combined mechanism. And today we are going with some more application of work method using combined mechanism. First, let me make a briefly review on the combination of mechanism that we have learned in the previous class. To determine the independent mechanism for the combined mechanism, first we first start with independent mechanism, right? And we have to determine the independent mechanisms. Do you remember how to determine the independent mechanisms? Number of independent mechanisms? We have equation small n equal to upper n minus r. What is upper n? N here equal to, is a number of critical section where plastic hinge might form. And R is degree of redundance of structure. For example, with this photo frame, n equal to 1, 2, 3, 4, 5. Then in this case, the number of critical section is 5. 1, 2, 3, 4, 5. How about R? Number of redundance or degree of redundance. We know the number of redundance is 3, right? For this structure, 3. Then R equal to 3. Then the number of independent mechanisms is 2 for this structure, okay? And we also already learned about the type of mechanism. How many types of mechanisms? The first one is beam mechanism, right? Beam mechanism. And second types of mechanism is panel mechanism. Panel mechanism, or sometimes we we call sway mechanism. Okay, sway mechanism. And the third type of mechanism is joint mechanism. And A, B, C here, beam and panel and joint mechanism are called, sometimes called, not sometimes, but they are called independent mechanism. Okay, they are independent mechanism. And the last one is combined mechanism. Combined mechanism. They are combination of beam mechanism and panel mechanism and joint mechanism. Sometimes it is portal mechanism because sometimes we combine between A or B and B or C or sometimes something like that. So it is portal mechanism. If we combine all of independent mechanism of structure of a current of a given structure, if we combine all of independent mechanism of a certain structure, then we have full combined mechanism. Okay, full combined mechanism. Okay, good. And back to the previous example. We already have n equal to 2. Then they are two independent mechanism. They are beam mechanism like this and panel mechanism like this. With the beam mechanism, we can write down the work equation. The work equation corresponding to beam mechanism is this is external work. External work, okay, equal to vertical load SC and multiply by this distance equal to 10 pi theta, 10 theta, then equal to 30 theta. Internal work here we have 1 and 2 and 3 inch. Then here theta and 2 theta and theta, and we have 1, 2, 3, 4 theta multiplied by MP equal to 80. Then for beam mechanism, it's like this. For panel mechanism, we have external work, internal work, okay, external work due to this one, and this displacement, okay, is external work, and here's internal work, 1, 2, 3, 4. And now we combine the two independent mechanisms. We have 30, 50 lambda and 160. But remember here we have this is minus theta, and in this angle is plus theta, okay, plus theta here. When we combine this beam mechanism and panel mechanism, then minus theta and plus theta, then this angle will be disappear. It means we have to cancel the hinge at B. This this hinge will be cancelled. Okay, will be cancelled. Then we have minus 2 hinge and multiply by 20. Because MP is 20. Okay. Then finally we have combined mechanism is the external work is identical, but the internal work is changed. Now equal to 220. Then for the combined mechanism, the solution lambda equal to 2.4. This is exact solution. And combined mechanism here is full combined mechanism, because we have only two independent mechanisms and we combine all of them. Then we have full mechanism, full combined mechanism. And with full combined mechanism, we have exact solution. Okay. Okay, so now we are moving to some more applications of combined mechanism or combination of mechanism. We consider two-story, one-bay rectangular frame, as you can see here. Two-story, one-bay rectangular frame. A, B, C, E, G, M, G8. Okay. The beam has length of 20 feet, and the columns has same height with 10 feet each column. The load, the vertical load for the first beam BG, the load is 40 lambda, and lambda here is the load factor, okay. And the load is at the middle of the beam, F and D. And the horizontal load is at B and C. At B is 30 lambda and at C is 20 lambda. Okay. So, what is a lambda? What is lambda? Then we have to determine lambda. And this problem is analysis problems. Okay. We are going to determine lambda means it is analysis problems. Okay, here we go. First, we have to determine the number of independent mechanisms. How to determine the number of independent mechanisms? First, we use this equation. The small n equal to upper n minus r. What is upper n? What is number of critical section where might form the hinge? The plastic hinge might form. Okay, let's see. And the number of critical section equal to 1, 2, 3, 4, 5, maybe 6, 7, 8, 9, 10, 11, and 12. So n here equal to 12. Possible hinge location. How about R? Number of redundance or degree of redundance. How many redundance of this structure? How many? R equal to 6, okay? 6, because 2 story. Here, maybe here's 3 and here's 3 or something. Then we have 6. R equal to 6. Then n equal to 6. Number of independent mechanism. Okay, so please note that in this structure we have two hinge, two joint in the mechanism, two joint mechanism. One may be at B and one may be at G. Two joint mechanism. So joint mechanism at B and joint mechanism at G are 2. Then we have a number of 2 independent mechanism. Number of 2 independent mechanism now equal to 4. Okay, so excluding the joint mechanism at B and G, then we have a 2 independent mechanism. Okay, so the total is 6, but the 2 mechanism is 4, and the joint mechanism is 2. Okay, so we have 4 mechanism. What independent? 4 independent mechanism. What is this? What they are? What are they? The first one is beam mechanism. CE, beam CE. Okay, beam mechanism. So this mechanism is called A mechanism. Okay, and what else? Beam BG. Okay, beam BG. Beam mechanism number 2 at the first floor beam. Okay, the second beam mechanism. What else? Panel mechanism. Panel mechanism of the second floor. Okay, upper floor mechanism. Then we have panel mechanism or mechanism number C. So A, B, and C. Sorry. And what else? The D mechanism are the panel mechanism number 2. Panel mechanism number 2. Okay. So we have, from now on, we have A and B and C and D. The first one is beam mechanism and the last 2 is panel mechanism. So we have 4 independent mechanisms here. Now, for A mechanism or the beam mechanism number 1, A mechanism, we can write down the work equation. Could you please write down the work equation for mechanism A? The external work. What is external work? External work is 30 lambda and multiply by this distance. What is this distance? It is 10 theta, okay? 10 theta. Because the distance from here to here is a half of the length of the beam, then it is 10 and 10 theta. So external work equal to 30 lambda multiplied by 10 theta. How about internal work? Internal work is 1, and 2, and 3, and 4. So let's say 4 theta multiplied by MP, 200. Then we have 800, okay? Okay, so for A mechanism A, external work and internal work, and shorten this equation becomes its equation, and finally we have lambda equal to 2.67. This is a solution corresponding to mechanism A. But we know that it is not a correct solution, okay? Just a solution corresponding to the first independent mechanism A. And similarly, for mechanism B, with mechanism B, we have external work is 40 lambda multiplied by 10 theta, okay? And internal work, same, internal work equal to 800, okay, 800. Then finally we have lambda equal to 2. This is solution. This lambda solution is corresponding to mechanism B. And also this is not correct mechanism. And we have C mechanism, mechanism C. With this mechanism, we have external work and internal work. External work here only 20 lambda multiplied by this distance. And this distance equal to 10 theta, okay, 10 theta here. 10 theta because the column has a length of 10 and this angle is theta, then this distance is theta, 10 theta. Then 20 lambda multiplied by 10 theta is external work, and here is internal work. And finally we have lambda equal to 4. This solution corresponding to mechanism C. And similarly we have mechanism D. With mechanism D we have lambda equal to 1.6, okay, 1.6. So each internal mechanism, independent mechanism, has each solution. They are not correct solution, okay, but it is a solution. And now we are going to combine mechanism. Now we combine the two independent mechanism. For example, we combine mechanism C with mechanism D. Okay, C combined with D, and it becomes mechanism E. Okay, what is mechanism C? C is panel mechanism number 1. Okay, panel mechanism number 1. What is mechanism D? D is panel mechanism number 2. Okay, so with C mechanism we already have external work and internal work. Okay, it's mechanism C. And mechanism D, with this mechanism D we already have external work and internal work. Now we combine C and D together. Then we have mechanism E. Here, take a look at joy at B and the joy at G. They are same, so I'm going to explain the joy at B and see G is similar, okay? Take a look at this joy. We have the columns and beam, and they are the same section, okay? They are same section. It means the section of beam and section of column is equal. Then MP is equal. Because they have the same section, then in this case, as you can see here, look why joy rotation here. In this case, because of the section of the beam and section of column is equal, the same, then in this case, this look why joy rotation at B close up, okay? Close up the two hinge at B. Then this joint with the hinge here and hinge here will becomes the hinge at beam. Okay, will becomes hinge at beam without the hinge at the column. Okay, so in short word, when the beam and the column has same section and there are two hinge at column, then this mechanism becomes this mechanism. Okay, so the hinge is occur at beam, not a column anymore. Okay, so by that phenomenon, one hinge is cancelled. Okay, so here we have two hinge, but now it's become one hinge. So one hinge is cancelled. So we have minus one hinge, minus one theta. Okay. Similarly, with this joint, it's become one hinge at beam. So one hinge is cancelled also. So we have two hinge. The total two hinge is cancelled, and the hinge now occur at beam. Then the combined mechanism E now become this mechanism. Okay, this mechanism. So here is real mechanism of E. Okay, combined mechanism E. It is real. Okay, so now because of the joint rotation at B and at G, so we have to minus two hinge. Okay, two hinge become 200 multiplied by 2 theta. And now combined mechanism. C and D. It is E mechanism. For E mechanism, okay, we have this is 700 lambda. Here is 800 plus 800 minus 400 equal to 1200. Okay, 1200. Then with this one, it is for combined mechanism E. Then the solution now is lambda equal to 1.740. 14. Okay, 14. This is solution of mechanism E, combined mechanism E. This is combination between C and D. Okay, that is solution of mechanism A.